right, today we are going to continue looking at coordinate proofs and mid-segment, but today is all about what a coordinate proof looks like. So if you notice, I went ahead and gave you a copy of a completed coordinate proof of the mid-segment theorem. So the difference between a proof with triangles and a coordinate proof is if you scan through the proof, you will see lots of formulas. So coordinate proof brings in more algebraic formulas to prove items. So we are given that we have a mid-segment of a triangle. We are trying to prove that you have a set of parallel sides and at the mid-segment that the other side of the triangle is half the length of the mid-segment, which is what the theorem tells us. So I want to just point some things out as we go through this one. We have our given. Now, in order to show that two lines are parallel, from an algebra perspective, they have to have the same slope. So what we're trying to accomplish in the first half of the proof is showing that the slopes are equal. So I need to calculate the slope in order to see that. So I've got line number 2 right here. I need coordinates for E and coordinates for B. So if we go back to the top, if this is a mid-segment, this is the midpoint of AD. So notice it is the formula x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So we took a plus 0, which is a, and divided by 2, and got a over 2. Same thing for B. So notice on this side, we've got, for the x-coordinate, we took a plus c and divided it by 2. Well, a and c are just a plus c. We did the same thing on the y-coordinates. We've got b plus 0 and divided by 2, so that's what we have. So line 2 is simply stating the two coordinates. And the way we did that is simply the midpoint formula. So on the reason side, we will be writing formulas or concepts related to how we wrote that item. Okay, number 3, we're starting to do slope. So I've got the slope of EB. So remember your slope formula is y2 minus y1 over x2 minus x1. So that's what I'm doing here. I'm taking E and B. So y2 is b minus 2. y1 is also b minus 2. So that's where we got this line, the numerator. Denominator is x2 minus x1. So here's my x2, and here's my x1. And so all I've got on the first line is I have everything substituted in. Now I'm simplifying. I'm going to subtract b over 2 minus b over 2, which is just 0. Okay, so that's where 0 came from. In the denominator here, the 2's are the same. So when I add fractions with like denominators, I can add the numerator. So a plus c minus a, notice the a's cancel out, and I'm left with c over 2. Well, 0 divided by c over 2 is going to be 0. So that's how I got my 0. In the next line, I want to show that, or actually I'm in my same line, I also want to show the slope of the other segment is 0. So we run through the same formula. We've got y2 minus y1. And so if you go back up to the top, the y2 minus y1, I've got 0 for y2 and 0 for y1. So that's how I got 0 minus 0. The denominator is c minus 0 here. x2 is c minus x1. So again, 0 divided by anything is 0. And so what we were doing in line 3, we write the name of the formula. The reason we did that, we were doing the slope formula. So line 4, we have just shown that these two lines are parallel. And what I've got over here is I just restated the property. If you have equal slopes, that leads to parallel lines. Okay, so I have just accomplished this first part of the proof, okay? Now I need to move on to the lengths. So if I'm trying to show that EB is half of DC, I need to know how long those segments are. So look at line 5. I am using distance formula to do that. So I'm taking my time and I'm plugging into distance formula, and it looks really messy, but you really just have to slow down and substitute in. So right here, I've got a plus c over 2. So your distance formula, remember, is x2 minus x1 squared plus y2 minus y1. So go back up to the top. x2, now I'm looking at segment EB. Segment EB. Okay, here's segment, let me switch colors here. Here's segment EB. So my x2, a plus c over 2, my x1, a over 2. And so that's what we have here. I've got a plus c over 2 minus a over 2. And then I've got the same thing here on the y's. So let's go to the simplifying. These are, the 2's are a common denominator, so a plus c minus a, I am just left with c because the a is canceled. Over here, b divided by 2 minus b divided by 2 is 0. So 0 squared is just 0. So that's why I have nothing written except for c over 2 squared. So when I square a number and I turn right around and take the square root of it, they undo each other. So that's how I'm left with c divided by 2. Or I switched it to 1/2 c because I'm trying to prove that EB is half of DC. So I know that right now I've got EB is equal to half of C. Now I want the length of DC, and I just ran through distance formula again. So I substituted in my x2 minus x1. So I have C minus 0 squared. Well, that's just C squared. And then 0 minus 0 is 0, so that's gone. The square root of C squared is just C. So I have just shown DC is equal to the letter C, and right here I've got EB is half of it, so I have just shown that EB is half of DC. And so the way I got that is I am substituting. So I have substituted into my EB and my 1/2 C, my DC, and what I got for C. Okay, so there is a lot going on in that proof. That's a pretty long one. We are just going to focus on 2 others that are not quite as long. But what I want you to take away, do not be scared by all the letters. Okay, we're just using formulas that you already know. And then we're just going to simplify through algebra. Okay, first one, we are going to write a coordinate proof. If we are given that we have a square, we are trying to prove AC congruent to BD. So these are the 2 diagonals. So I'm trying to prove that these 2 diagonals are equal. All right, so I think I already have on yours. I think I have yours numbered. So number 1, we're still going to start with our givens. So we're going to write here that square, just recopy the given. Square ABCD is given. So line 1 over here is given. Okay. Okay, line 2. If I'm trying to show that the diagonals are congruent, I need the length. So let's calculate the length of AC. I need to use my distance formula. Okay, so AC, I'm going to say x1, y1, x2, y2. So let's plug into the formula. It's x2 minus x1. So I'm going to take a minus 0, the formula says squared, plus y2 minus y1. 0, oops, this is actually y2. That's what I meant to label. So 0 minus a squared. Okay, now let's simplify. Well, a minus 0 is just a. And then negative a minus 0 is negative a. Okay. I can squeeze in here a little bit more. So if I square everything, I have a squared plus another a squared. Because when I square a negative number, I get a positive. All right, I'm going to go back here to this line. So a squared plus a squared is 2a squared. Okay, and I can simplify that down. If I take the square root of a squared, I get a, but 2 is going to have to stay under the radical. So line 2 over here, I'm going to write down the formula I'm using, distance formula. Okay, within this same line, I'm going to also calculate the length of the other segment, BD. So I need to do distance formula again. Okay, so BD, I'm going to label, let's see, I'll call B X2 and Y2, and I'll call D X1 and Y1. So plug into your formula. So I'm going to have A minus 0 squared plus another A minus 0 squared. Okay, I've got A squared plus A squared. Well, that's just A squared plus A squared. And when I combine like terms, I get 2A squared. Notice I'm getting the same thing I got above. So the length of BD is A times the square root of 2. So I've just shown, I can tell these are equal to each other. So I need to get my proof to say that. Now, I'm trying to show the segments are congruent. So I need 2 more lines because I'm going to show that the lengths are equal, and then I'm going to switch over to segments. So, number 3. I can now show that AC, I've now shown that AC is equal to BD, and I have just substituted. Okay, I can substitute the length into the segment. So I did substitution. And then I need to convert back to segments. So now if the lengths are equal, I can say that segment AC is congruent to segment BD, and that's a property called definition of congruent segments. Definition of congruent segments. And that is our coordinate proof. So I've got lots of formulas, lots of algebra. Okay, let's look at our second one. We are given 3 ordered pairs, which forms a triangle. We are proving that this is a right triangle. So number 1, let's start out with our given. And we're just going to write the ordered pairs down. So A is 0, 2. B is 4, 7. C is 9, 3. And that is given. Okay, I'm trying to show I have a right triangle. So number 1, I need a right angle. So my proof here is getting all the information in there to prove I have a right angle. So I am going to prove, we are now going to show that B is a right angle. Now, I'm on a coordinate plane, so in order to show I have a right angle, I want to show that AB is perpendicular to BC. In order to do that, so I'm going to make a couple notes here. I'm trying to show that AB is perpendicular to BC, and in order to do that, I need to look at slope. And so if my slopes are opposite reciprocals, I have just shown it's a right angle. Okay, so this is kind of mentally what we're going for. So my next step, I have to calculate some slope. Okay, number 2. I need to calculate the slope of AD and BC. So I'm going to say M, and then I'm just going to put a lowercase ab there. So my slope formula is y2 minus y1 over x2 minus x1. So I'm going to do that with A and B. So I'm going to take 4, or not 4, excuse me. We want y2. So I'm going to take 7 minus 2. And then that will be divided by 4 minus 0. Well, 7 minus 2 is 5. So I have 5/4. Let's calculate the slope of the other one as well. So I also want the slope of BC. So I'm going to do the same formula. So I'm going to this time have 3 minus 7 over 9 minus 4. 3 minus 7 is negative 4 over 5. Okay, number 2, we write down the formula we used. We use slope formula. Okay, I can tell these are opposite reciprocals, but I'm going to bring back part of the theorem that we don't focus on as much, is that if these are opposite reciprocals, their product is negative 1. So I'm going to show that 5/4 times negative 4/5 is equal to negative 1. And so this third step, again, we're bringing in algebra or mathematical items. Actually, just going to write multiplication. This is a mathematical proven process that we can refer back to. And so in step 4, I'm going to recall the theorem that says that if I have a product of negative 1, the lines are perpendicular. So I can now say that segment AB is perpendicular to segment BC. And I'm just going to summarize that. I'm going to say product of slopes. The product of the slopes is equal to negative 1. And then I'll just use an arrow to indicate that leads to perpendicular lines. Okay. So I'm almost there. I have just shown that I have a perpendicular lines. So if I have perpendicular lines, I know that that makes a 90-degree angle. So I now know that the measure of angle B is 90 degrees. And I know that because I know the definition of perpendicular lines. So definition of perpendicular lines. And then now I'm ready to finish with my prove line, which is ABC is a right triangle. So triangle ABC is a right triangle. And so number 6, if I have a right angle, by definition, it's a right triangle. So definition of right triangles. Okay, well, I want you to take a moment and summarize what we just did. I want you to go to your summary page, and I'd like you to summarize, and you probably have a lot of questions. I'd like you to write down some questions you might have that we can address later. Once you've done that, then you can get started on your assignment.